4.3, writing linear equations in point-slope form. The two formulas that we're going to need is the slope formula and the point-slope formula means that we're going to have a point and we're going to have a slope. The formula is y minus y1 equals my slope times x minus x1. We have a point, and that point is x1 and y1. Notice that x1 and y1 have negatives in front of them. If x1 was negative, it would be a double negative. The same for y1. If the y1 was negative, then there would be double negatives here. So be on the lookout for double negatives. We also have slope. And our slope is here in front, being multiplied to the parenthesis. What does it mean to be x1 and y1? Well, the same thing that we saw when we had the slope formula. That means that we have 0.1, x1, y1, and 0.2, x2, y2. Those are subscripts, not exponents. The first step says use the slope formula to find the slope of a line. We're going to use these 2 points, 3, 2, and 6, -1, and we are going to find the slope. So we have slope equals -1 minus 2 divided by 6 minus 3. We get -3 divided by 3. So our slope is -1. Step 2, substitute the slope and one of the points into the point-slope formula. We have the point 3, 2 and 6, -1. Which point should we use? It doesn't matter. Either point, but I'm going to choose the one that has no negatives. So it says that we need to have a slope. Our slope is -1, and I'm choosing the point 3, 2. This is called the point-slope formula. So we're using a point and a slope. I'm going to write down the point-slope formula. That helps me to memorize it. The more that I write it, the more I'll have that memorized. So that is y minus y1 equals my slope times x minus x1. Here is our x1 and y1. And here is the x1 and y1. We also have our slope. And here is the slope. All right, we are ready to substitute. So we have y minus. Y1 is 2 equals my slope, -1, times x minus x1, which is 3. Now here's the equation. Here's one acceptable way to write your answer. But we need to be careful, and sometimes in the directions it will ask you to simplify to slope-intercept form. It could also ask you to simplify to standard form. So this would be y equals mx plus b. And you could also simplify to standard form, which is ax plus by equals c. So you've got to make sure that you read the directions. If it doesn't say to simplify to any particular form, then your final answer can be right here in point-slope form. We're going to practice today simplifying this into slope-intercept form. So we have y minus 2 equals -1 times x minus 3. We need to simplify. We have the distributive property, -1 times x, and -1 times -3. We want to get rid of these parentheses. So we have y minus 2 equals -1 times x. -1 times -3 is positive 3. The last thing that we need to do to put it into slope-intercept form is to get y by itself. So if I add 2 to both sides, we get that y equals -x plus 5. Let's try another example. The first thing that we're going to do is find our slope. So we have -2 and 3 for our y values. So -2 minus 3. -2 minus 3. And then we have -5 minus -4. -5 minus -4. And we can see here that we have double negatives. So -2, -3 is -5. First, we're going to clean up those double negatives, and negative times a negative is positive. That means that we have -5 and +4, which would be -1. My final answer for slope then is -5 divided by -1 is +5. Next, we need to substitute in our slope and a point. And I'm going to choose -4, 3. So we have our slope is 5. And I'm choosing the point -4, 3. Now, both of these points are going to be on the equation of the line, so it doesn't matter which one you choose. I'm just choosing the one that doesn't have two negatives. All right, so I'm going to write my formula. Y minus y1 equals my slope times x minus x1. We have y minus, our y value is 3, equals my slope of 5 times x minus x1 is -4. So there you're seeing that double negative. We can't leave our answer in point slope form like this because we do have some simplifying here to do. So we need to clean up those double negatives, and that would be y minus 3 equals 5 times x plus 4. So if the directions don't say which form to put it in, I can leave it in point slope. Simplified, no double negatives. But today we're going to continue in practice. Let's practice putting it into standard form this time. So we have y minus 3 equals 5 times x plus 4. We're going to use the distributive property to get rid of those parentheses. Y minus 3 equals 5 times x, which is 5x, and then 5 times +4 is +20. So we're going to put it into standard form, which means we want our x and our y to be on the same side of the equation. We want to make sure that our a is not negative and that it's not a fraction. So I look to see where my x is, and it's only about the x. I don't want my x to be negative. So here my x is positive. I'm going to leave my x here then, and I'm going to bring my y over to the x. And I'm going to take my 20 and put it on the left. Let's start with moving the 20. So the opposite of a positive 20 is a negative 20. We have y minus 23 equals 5x. The last step would be to put the y on the right-hand side. The opposite of a positive y is a negative y. And so we have negative 23 equals 5x minus y. It doesn't matter that the y is negative. We just want to make sure that our a value here is going to be positive and not a fraction. So we have standard form. And we have slope-intercept form. And then, of course, we have the point slope form. So, depending on what the directions are asking for, we can have any of these three forms. We can choose, or the directions will choose for us. We have standard form, ax plus by equals c, slope-intercept form, y equals mx plus b, and then we have the point slope form. We've already talked about the point slope formula. We have the point x1 and y1. And then we have the slope m. Example 3, graph the equation y plus 2 equals 2/3 times x minus 3. I don't need to simplify this to put it into slope-intercept form. I can graph point slope form. I want to know what the point is, and I want to know what the slope is. What is the point? What is the x1 and y1? Here's x1. Y1, it doesn't say y minus. What would this look like? Because the formula says y minus y1. This doesn't say y minus. This says x minus, but here we need to manipulate that a little bit. That would be y minus, how can I get a positive 2 if I had a double negative? Now I can clearly see what that y1 value is going to be. It is negative 2. The formula says y minus. Really, the minus sign is negating the value. So I could say the opposite of 2 would be negative 2. The opposite of negative 3 would be 3. That's how you can think about this, because we have a negative sign that's negating the value of x1 and y1. So just think about the opposite. What is the opposite of 2? Negative 2. What is the opposite of negative 3? 3. We have 3 and negative 2. What is the slope? The slope can be found in front of the parentheses. So the slope here is 2/3. Now we can graph. We just need a point to start from. Here we don't have the y-intercept. We always had the y-intercept. We would start on the y-intercept and then we would rise and run. This time we have a point that's going to be in the quadrants. So we're going to go to 3, negative 2. X is 3 and y is negative 2. There's my first point. Now from that point, I'm going to rise and run my slope. So from this point, I'm going to rise 2 and run 3. Now I have 2 points that determine a line. All right, that's how you graph in point slope form. Why do I want to do all that algebra? Multiply by 2/3, have fractions, have to find common denominators, when I can just graph with a point to start with and then the slope. The important part about picking your point, again, is going to be about those signs. Example 4, write an equation in point slope form. So here they're telling you what to write, an equation in point slope form. So that means we have y minus y1 equals my slope times x minus x1. They've told you exactly what form that they want it to be in. So all I need is a point and a slope, and I can write my equation. All right, we have 2 points on the graph, and again, it doesn't matter which point you choose. You can choose either one, and when you simplify it down, you're going to see you get exactly the same line. I'm going to choose the point negative 1, 3. Normally, I would pick the one that doesn't have any negatives, but I'd like to practice using those negatives. Now for our slope, we are going to rise and run to find that slope. So I need to rise 1, 2, and then I need to run 1, 2 in the negative direction. So my slope is rise 2 and run -2. My final slope is -1. I have a point, I have a slope, I am ready to write my equation in point-slope form. Here we go. Y minus y1, which is 3, equals my slope times x minus, and x1 is negative. Double negatives. Can I leave my equation like this? I need to simplify those negatives, and then I'm done. So we have y minus 3 equals -1 times x plus 1. Final answer. Example 5. You are designing a sticker to advertise your band. A company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. Write an equation that gives the total cost in dollars of stickers as a function of the number in thousands of stickers that are going to be ordered. Find the cost of 9,000 stickers. All right, so the first thing that we're going to try to identify is, what is the rate of change? What's the slope? We see, let's see, a company charges $225 for the first 1,000 stickers, and then each $80 for each additional, okay, $80 for each additional 1,000 stickers. There is that rate of change. Okay, and then the last part is so we need to write an equation, and then we need to find the cost for 9,000 stickers. That rate of change is going to be $80 per 1,000 stickers. We also know from the given information, we have $225 for 1,000 stickers. So that's going to be, we have 1,000 stickers for 225. That would be the point. Remember that we're doing point slope right now. So we were looking for a point and we were looking for a slope. We are going to use the point slope formula. We know that our slope is 80 per 1,000. We are going to substitute our slope. Let's rewrite our slope as $80 per 1,000 stickers. We're going to use the 1 to represent thousands. So we're going to say 80 per 1. So our slope is 80 per 1. And we have x minus x1. Again, we're going to use 1. So this is going to be 1 for stickers and then 225. So our x1 value is 1, x minus 1. And then we have y minus 225. All we have to do is simplify. We get y minus 225 equals 80 times x. It's going to be 80x. And then 80 times -1 is -80. We're going to put the 225 over here and get y by itself. We get y equals 80x and then 225 minus 80. All right, we have an equation. We know that the cost, this is really C, and this is stickers. The cost equals 80 per 1 sticker plus 145. So the cost equals $80 per 1 sticker plus 145. And we need to find 9,000 stickers. So the cost for 9,000 stickers is going to be 80 times 9 for 9,000 plus 145. The cost equals we have that the cost of 9,000 stickers is $865. Example 6. The table shows the cost of visiting a working ranch for one day and night for different numbers of people. Can the situation be modeled by a linear function? That's the first question. Can this situation be modeled by a linear? Is this a linear function? Explain. If possible, write the equation that gives the cost as a function of the number of people in the group. So they want to know if our data is linear. The first thing that we're going to do is we're going to look at the slopes. We're going to look at the slope to see if the rate of change is a constant and changing at the same value. So let's look at, we have 4, 250. And we have 6, 350. We're going to find the slope. Subtracting our y values over our x values. And we get 100 divided by 2, which equals 50. We're going to look between 6 and 350 and 8, 450. The slope here is going to be 450 minus 350, and then 8 minus 6. Again, we get 100 divided by 2, which equals 50. If we look between 8 and 10, we get 100 divided by 2, 100 divided by 2. So we can see that the slopes are the same. They're changing the same between each set of points, which means it's going to be a linear function. So if it's a linear function, then we can write an equation. All right, so we're going to pick one point. We'll pick 4, 250, and our slope we just found was 50. So we have y minus 250 equals our slope times x minus 4. Let's see, if it's possible, write an equation that gives the cost as a function of the number of people. So we need to put this into y equals mx plus b. We want to see the cost, y, as a function of the number of people, x. We're going to simplify with the distributive property, 50 times x. 50 times negative 4 is negative 200. And then we're going to finish getting y, or the cost, by itself. So plus 250 plus 250, and we get y equals 50x and plus 50. So we're going to use the variables in the problem, cost and n for the number of people. So y is about the cost. So we have the cost equals 50 times the number of people, n, plus 50. Here is an equation that gives the cost as a function of the number of people in the group.